All right, 8.1, ratios and proportions. We're going to first start looking at ratios. And ratios are different than um, a rate in the fact that they have the same units. Like a rate might be miles per hour, um, different units that they're comparing, how many miles you can go in an hour, that's a rate. A ratio, you're going to have the same units. So you can use ratios to write ratios of boys to girls or something like that. You can say 5 to 3. Okay, A to B, maybe I should do that. A to B, you can write it out with the word 2 between, or you can write them as a fraction. So if we want to simplify ratios, what we're going to do is we're going to take and get the same units. So you have to change either meters to centimeters or centimeters to meters. In this case, I'm going to change this one to 15 over 200. And then I can reduce that down by dividing by 5. And I get 3. 5 goes into 20 4 times 3/40. Um, Here, get like units. Once again, I'm going to change feet into inches. So there's 12 inches in a foot. So 36 inches then to 9 inches. And now our units cancel and I get 4 to 1. And I'm going to leave it as a ratio here and not just write 4. In this next example, the perimeter of a rectangle ABCD is 98 centimeters, and the ratio of the side length BC to DC, the order that they said this matters, is 5 to 2. Find the length and the width of the rectangle. So first off, I have to figure out what is the length of these two sides. They told us the whole perimeter. The length of these two sides is going to be 49, right? Half of the 98. And from there, I'm going to write, I have two variables right now. I'm going to make it so I only have one variable. So I'm going to pick one of the sides. Maybe I'll pick this side and I'll call it L. And rather than calling the other side W, if this is L, this side is going to be 49, the total length, minus whatever length this is here. So 49 minus L is going to be the length of DC. And now I can write a proportion where 5 to 2. Okay, so a proportion is when we set two ratios equal to each other. So 5 to 2. Now, the 5 corresponded to the BC, and the 2 corresponded to the BC. So BC has to go across from the 5. BC was what we called L, and DC is what we called the 49 minus L. Now we can go about solving this. And you've probably seen before, and we're going to talk about it later. So one of the properties of proportions are their cross products are equal. So I can take 2 times L, and also I'm going to take 5 times the 49 minus L. And now I can solve this for L to get my answer. So 245 minus 5L equals 2L. I'm going to add 5L to this side and get 7L equals 245. And when I divide that by 7, 7 goes into 21 3 times. I left with 3 left. 335. 7 goes into 35 5 times. So we come up with a length of L of 35, And then that means we're going to put 35 in for L here, and we get 49 minus 35, and we get DC is 14. BC is 35. Okay, that's the length and width of that rectangle. The measures of angles in a triangle are in the extended ratio 3 to 4 to 8. Okay, so find the measures of the angle. So in this case, you can draw your triangle and you know the ratio is 3 to 4 to 8. Well, the easiest way to do this is going to say this angle is 3x, this angle is 4x, this angle is 8x. So we have some constant of x. And when we multiply by 3, 4, and 8, it's going to keep the ratio 3, 4, 8, extended ratio. Okay, extended ratio has not comparing just two things, but more than two things. And then in this case, we know all the angles add up to 180. So you can say 12 plus 3, 15, x equals 180. And when we divide by 15, we get x equals 15 would go in there 10, we'd be left with 30, so 15 goes into 30 twice. We get x equals 12. Now, find the measure of the angles. We're not done yet. We found x is 12, but we'd have to say this angle is 36 degrees. 3 times 12. 4 times 12 is 48 degrees. And our last one is 96 degrees. That would be our answer. I'm going to skip over this example. Feel free to pause it and try it on your own. And get on to more about what a proportion is. Okay, so like we said, a proportion is two ratios that are equal. And in a proportion, we talk about means and extremes. So if I read this proportion to you, I'd say A over B is equal to C over D. Notice I read A and D last. A over B equals C over D. A and B are what we call the extremes, okay, because we say them first and last. And the means are the middle, okay? And one of the properties that we're already used already, but the cross product property says that your means, the product of your means, I should say, of the means equals the product of the extremes. So basically, A times B equals D times C from up above. Now the reciprocal property is kind of similar. If you know what a reciprocal is, basically if I look at the reciprocals of this statement, B over A, that's going to equal D over C. Okay, so if this statement is true, then this one is true. So if I want to solve for x, I'm going to use that cross product property. 3 times 4 equals 5 times 12. And if you think back to 7th or 8th grade, we talked about 3 times 4, and we got equals 5x. Well, if I want to know what x is, I have to divide by 5. So we took 3 times 4 and divided it by 5 to figure out what x is. Cross multiply and divide. That's where that comes from. 12 divided by 5 would be my answer. And if you wanted, 5 goes in there 2 whole times with a remainder of 2. This last one is kind of like that second example. We have more than one variable in here. Solve it the same way, but this time you can't just cross multiply and divide because you have two variables. You have to take this quantity, and I'm taking that whole quantity, and I'm multiplying it by 10. I'm trying to be careful to not confuse my s's and my 5's here. Equals 4s. So I have 10s minus 50 equals 4s. I'm going to add my, well, I'll subtract my 4s and add the 50. Okay, so I'm going I do this and add 50, so I have to do the same thing to the other side. And I get 6s equals 50, and divide by 6. S equals 6 goes in there 8 times, and a remainder of 2, so 2/6 or 1/3. There's the homework.